Okay, for today, I am getting you ready for a test that you are totally not ready for yet. But you know a few of the things. I want to practice writing equations right now. All right, so let's do one of the classic, fairly easy kind, because you can all relate to it. You've all probably been to like a show where you buy tickets to go to the show. And it could be, maybe it's just a regular movie, and let's keep it that way. You go to a movie, and do you get that there are some theaters that have a different price for children and different price for adults? All right, so we're gonna say the child, write this down, price is $5, and the adult price is $8. So the movie theater takes in $400 one day, but they didn't know how many children's tickets and how many adult tickets that was. They just knew that they got $800. Can you write an equation for that? You can. Now, one of the things that you'd need to know is what variables should I use? Always use X and Y because we're graphing these things and you don't want to get confused which goes where on the graph, okay? And then of these two, there is no logical way to know for sure which one's X and which one's Y. Now, if I graphed it for you, you'd be able to tell, and I'm going to do it that way. Now you should be able to tell what's what. All right, write the equation for that. I'm going to pause while you give that a shot. Now, this will be really critical to be able to compare with the kid next to you. But I got to pair you with people. Otherwise, if you just happen to go to the person that's on one row or the other, then you might be leaving somebody out. So please compare with who I tell you to. Okay. Now, at the beginning, you could have picked child as child as X and adult as Y. And then when you looked at this, you didn't have a choice anymore. Child has to be X. And if you didn't do it that way, you didn't do it right. Okay, so X goes for children, and then Y goes for adults. How come I know? Because it was labeled right here. Okay, next is 5X plus 8Y has to be, well, in this case, I said they got $400, so it's equal to 400. Now, from that alone, do you know for sure how many children and how many adults were there? No. Like, let me challenge you. Do you even know that there were any children there? No, could have just been all adults. And in that case, it would have been 8 times something equals 400, and they would have had 50. You know, there's a lot of combos that are possible. Or there could have been just 2 children there, and then there would have been 49 adults. And there's lots of combos, and that would make an equation, right? Like a line of a whole bunch of points. All right, next, I'm going to change the problem to... The person said, yeah, I think we made a little less than $400 that night. Well, obviously that changes it. To me, that means that you could phrase it as maybe that's less than or equal to 400. And that allows you to shade underneath that line. All right, next thing. If you had to put that into a calculator, some people would be stumped because they're like, my calculator, the only way I can put those in is if I say Y equals. And I don't even know how to do it then. All right? Well, talk to the kid next to you and try to put it into your calculator. There's a way. And no, it's not typing 5x plus 8y on the line. That doesn't work at all. All right? So see what you think. Talk to them. Use your brains together. Yes. I heard 2 good things. I heard one group say, do you just get y by itself? Yup. And then I heard another group say, I think you just subtract 5x. You are correct, except then I'll have 8y is less than or equal to, I'm going to put the minus 5x first. And just because I like having the slope like that. And then you can't just graph that either. Why? Moreno.
Because the y is not on its own. You need to divide both sides of the equation by 8.
You are correct. So divide everything by 8. Now, that might make for a gross fraction. Well, deal with it. You got to be able to handle that. Okay, get that into your calculator and then hit graph. And then you're going to realize, wait a minute, those numbers are so big that I can't even see the equation. Like you'll hit graph and your graph will be blank because your graph only goes from about -10 to 10 in both directions. The x goes from -10 to 10 and the y goes from -10 to 10. So if you hit graph and there's nothing there, that doesn't mean that your calculator's messed up. It means your window is messed up. So there's a button that allows you to pick how far it goes in all directions. This is, of course, the x direction is like this way. That's the x's. And the other ones are the y's. And the window button is on the top row. Adjust that until you can see your graph. Now you've got a partner. I asked you to work with them. So if you're stuck, you're like, I don't know what he's talking about. Ask them first. And then if both of you are stuck, ask me. All right. So now you have graphed this. And everybody that I looked at anyway had it visible on your screen. Okay. Now I'm going to give you another equation. And this is one that's, again, based on our movie theater problem. Would you agree that somebody could have looked up how many total tickets and just counted them? Somebody could have done that and said, yeah, we figured it out. We had a total of 41 tickets sold. That's an equation. I'm going to say it again. Write me an equation for there was a total of 41 tickets sold. Then you're going to graph that equation. But first, write the equation and talk to the kid next to you about what equation, if there was 41 tickets sold. So that it leads us to x plus y has to equal 41. That's an equation. Can you graph it exactly the way it is? No, but you could solve it for y really easy and then put it in. Now, will that intersect the other line? It probably will. And then your job is to see if you can see where they intersect. If your graph doesn't show where those two lines cross, you got to fix it so that you can see where they cross. You might see, well, I know it's going to cross, but on my screen they're not actually crossing. Well, then you have to make your window different so you can see where those two lines cross. If you can see where they cross, then you're ready to do what we did yesterday, which was second calculate intersect. See if you've got the brain power to remember how we did that yesterday. And if yours says intersection at the bottom, I know you did it right. Nice job. Yay.
How do you do it? Okay, so now that you're there, you just go to and then you gotta put like that.
Why when you see what your equations are.
Yeah, that's.
Here's actually, you wrote it as fine here, so the second one is negative x plus 4. Let's see if you can see where they cross. Yeah. Let's see if she got the same intersection. Yeah, she did.
Negative x, y.
The trace.
Usually it's an intersection. Okay. It does, yeah, you think. Intersection. You're using trace. Trace would be.
No, okay, here's x plus y equals 45, right? You want to subtract x from both
For
sides,
both
and you
trace.
get y equals negative x plus 40.
All right, I was able to walk around and find out that almost everybody had it. Lindemann, I never checked yours, but I bet you have it. What's the intersection point? What comma what?
I did not get it.
Oh, boo. Okay. Hope, did you get it?
Like negative 26, 65.
Nope. Okay. So I'm pausing for a second. So I know a few people are still having tech issues, and the two equations you will need are right here. I'll put them back up on the board. You have to graph this one and that one. Okay, and then you got an answer. Marina, what you were saying that the answer kind of bothered you. What was the answer, first of all?
It was negative 2465.
And in the context of this question, what does that mean?
That means you would have to have negative 24 children.
Yes.
It's not possible.
You can't have negative 24 children. You are correct. So do you get that the math of it works? It actually, you can have 65 adult tickets and then subtract off negative. But in the real world, you can't have negative tickets. All right. So this one, if you found this, that means you know how to do intersect. Yay. The bad part would be that those intersected in a place that wouldn't have realistically worked. Okay. All right. So next, we're going to get two completely different equations. And if you got lost on the last one, come back to me and get this one instead. All right. For these two, we're going to say that this equation right there is y equals negative x plus 8. Next, we're going to have another one that goes steeper than this. And it's going to be like that. And it'll be y equals negative 2x plus 12. Those two should intersect. Would you please find that intersection point? I'll pause for a second while you guys just find that intersection point. Okay. Once you've got them graphed and you can see where they cross by adjusting your window, if you can't see where they cross, the intersect thing won't work. But if once you've got them crossing, you go second, calculate intersect, you hit enter 3 times, and poof, you've got your answer. Hope, what did you get this time? 4, 4. Raise your hand if you also got 4, 4. Okay, awesome. Now, let's say that this is one of those feasible region questions, and I shade in, watch closely where I shade in. Would you agree that that spot, 4, 4, is part of the feasible region? The feasible region is the shaded in little shape. Okay, does that make sense so far? All right. Would you please figure out by using your brain, maybe not even your calculator, what that spot is and what that spot is? Hint, this is the x-axis, which makes y equal to 0 there. And this is the y-axis that goes up and down here. And the y-axis is where x is 0. You should be able to figure out these 2 points. I'm going to pause while you talk to the kid next to you about the 3 important corners. We all know this is 0, 0, so I'm not even saying it, but you should be able to find the other 2 vertices. On the x-axis, along this line right here, you would set y equal to 0, because the x-axis is where y equals 0. So if I wanted to know this spot right here, that where the blue one touches the x-axis, at that moment, at the x-axis, y is 0. So you'd set this equal to 0, and you'd figure it out. And then I can tell that x would have to be 6. Raise your hand if you figured out that that was 6. Awesome. So on the x-axis, y is 0, and the x would be 6. So that spot is 6, 0. All right, Tyler, use the same logic on the other axis. It's a y-axis, and therefore...
Make the x 0.
Yep. And if I make the x 0 here, I'm trying to find this red line. Put a 0 here. No. Yeah, put a 0 there. Yep. And then it'll tell you what y is. What's y equal to?
8.
Yep. 0, 8. All right, now the end of a problem like this usually goes like this. You've graphed the 2 lines, or maybe there's even more, and you shaded it all in, and you found all the corners. They're called the vertices of the feasible region. And we just did. We found all the corners. That wasn't that hard. Now here's the actual question. So imagine a world where you are selling stuff at a bake sale, and you have brownies, and you have cookies. And I just put them in the right spots, so you should know which one is which. You can make brownies, you can make cookies. And you figure out that after paying for your expenses, brownies on average will make you $1.25 of profit. And the cookies are only going to make you 75 cents profit. I'm going to say P equals and P equals. P means profit. So generally, would you agree that you would like to make the most profit at your bake sale as possible? We want to maximize profit, generally. You want to make money at your bake sale? Okay. So then you have to decide which makes you the most profit. Now, there might be reasons why you might say, even though this makes the most profit, I'm not going to do that. But you got to figure out which makes you the most profit. So you make a list of all of them. 0, 0, I wouldn't make you list that because we all know that makes nothing. 0, 8 makes you something. 4, 4 makes you something. And 6, 0 makes you something. Figure out the profit at each spot. And then you're going to ask the kid next to you if you don't understand what's going on. Brownie's profit is there. Cookie profit is there. I'll pause. All right, we're running short on time. Jackson, can you tell me what 0, 8 got you?
0, 8 would get me $6.
$6. I believe he's correct. Anybody else get 6? Because it was 0 X profit, and the Y's, there was 8 Y's. 8 times 75 cents. This next one has 4 brownie profit and 4 cookie profit. Isabella, is that how you did it? Okay, so can you tell me what you got?
I got $8.
Anybody verify $8? Okay. That should have been 4 times $1.25 and 4 times 75 cents. All right, last one is 6, 0. I got 6 X's, which is 6 brownies, and nothing else. Hakan, what'd you get for that one?
7.5.
7.5. What makes us the most profit?
4.
4. Right here. This one wins. Makes us the most profit. Does that make sense to you guys? right. So, your challenge for tonight is to do just one problem from start to finish. That involves writing the equations for it, graphing the equations, shading the right way, figuring out where they touch, where they cross, that's the intersection points, and then figuring out what's the most profit. So would you please open the worksheet right now, and it's only problem 3. That's the only one you're doing. To try to keep it reasonably sized homework tonight. But it's gonna be a huge difference if you don't do it. Because all we have left is one review day in the test. If you don't practice this tonight, you're pretty much toast. This is a hard test. If you practice this tonight, you'll be all right. You still have all day tomorrow to master it. All right, now this problem 3, once you read it, you'll realize there's no profit. So there is an equation like this that you want to optimize, but it's not profit. I think, if I remember right, I think what you're optimizing is miles per gallon, but I'm not sure. You have to figure it out. Look at the problem, figure out what they want to optimize. Like, do we want the most profit? No, there isn't any profit in problem 3. You'll have to figure out what you're optimizing. They tell you, it's in the problem. And at the end, you'll have 3 or 4 spots you got to check, and you got to figure out which gives you the best of what you're trying to optimize. Sometimes you want the smallest amount. Like if it was about spending money and you're a big company, you want to spend the least money you can. Maybe that's optimizing too, but it's trying to figure out what's the smallest amount. All right. Okay, so you have that one problem. When you get stuck, which you might, go look at the key. Remember, the test is coming very soon. Try to figure out how you should have done it. Don't look at the key within 5 seconds or you're not even trying. Give it a shot. Look at the key when you get stuck. That's all I got for you for today.